Good day, viewers. You are welcome back to Tindanious Maths and Science tutorials. Let's go straight to the point. This is a suspected question. Alright, this can come. You can meet this at any point in time because it really seems complicated, but it's very, very simple. Where you are going to apply all the principles regarding horizontal and vertical shift, compression, what have you, reflection in the x-axis, reflection in the y-axis, and so many stuff with coordinates given. So for this question, you can easily score everything and you can easily deviate. Alright, so let's strictly adhere to the principles. Alright, if this is your first time, kindly visit my previous lectures where I've dealt with this into details, where I started from the scratch, easier to understand and appreciate. So solution. So giving h of x equal negative 4g negative 3x plus half plus 5. This time around, the constant is already isolated, so you don't need to do justice over here. Alright, so you have to do justice to this. You have to factorize. So I have h of x is equal to, I have negative 4g. Then I can bring negative 3 out. Then I have x. Let's have 1/6. Let me do this here and see. Plus 5. Let's see if the factorization is correct. I factored negative 3 out. So negative 3 by x gives negative 3x. So this is correct. Negative by negative gives positive. That's correct. Then 3 divides 6 2 times. So I have 1 on 2. That is correct. Okay. Alright. So having done this, let us now apply the principle. Let's first focus on this, right? So we want to find for k. So k is equal to 1 over the absolute value of b. Is that also? So I have 1 over the absolute value of negative 3 becomes positive 3. So I have 1 on 3. So we have horizontal. So we have horizontal compression by scale factor. Which is my k of 1 on 3. Is that also alright? So therefore, given the point, so we have 6 and negative 9. Whenever you hear horizontal compression, horizontal stretch, vertical compression, vertical stretch, you are going to multiply. You are going to do some sort of multiplication over there. Alright? So which one is the lowest one horizontal? I'm going to get this because x is the horizontal. Okay? So this is my x-axis along the horizontal. You get it that way. Alright, so I'll keep my y coordinate constant. So I have 6 over here. So compression times the scale factor, which is what? 1 on 3. So 1 on 3. Then comma, I'll maintain my y coordinate, which is my negative 9. So I'll have what? 3 divided is 2 times. So I have 2, comma, I have what? Negative what? 9. See, this is the first what? Procedure. So my second in order. So we are done with this, right? We are done with this. But look at something. There is a negative. Sorry, here. You are still here. Negative is attached to the thread. So I can't move from here, then focus on this. No, I have to do justice because of the negative over here. So realize that you are trying to negate the x part, okay? So when you have a situation where you negate the x, that means you are doing reflection in the y axis. Okay, see the questions we've been solving so far, negative wasn't there. So after finding for the scale factor, we then just straight away move to this. But here negative is there, so we have to do justice over here. So because we are negating the s component over here, that means we are reflecting in the y axis. So secondly, we have reflection in the y axis. So reflection in the y axis, you know that when you have a y comma this, when you reflect this in the y axis, that means we are going to negate the x and retain what the y. Is that not so? We are just going to apply the same thing. So the point we got for this, that will become our reference point. So I have what? 2, negative 9. Viewers, you have to be extra careful. So imagine you had the first coordinate to be wrong. That means whatever you do is totally wrong and you score what? 0. So be very, very careful when solving for it. So because this is correct, we are going to use the same, that's the coordinate over here to work out for the rest. So I'll have what? Here x has been negated, right? So I'll negate x, which is 2, then I have what? My negative 9. Afterwards, I'll proceed using what? The current point. So imagine this is wrong, everything will be wrong. You get that way? Alright, so we are done with this. So let's come here. We have, alright, so we have this. So that's reflection in the y-axis gives this coordinate. Okay, so what are we supposed to do next? We are now going to tackle this. Is that okay? So we said we have x minus 1 over 6. We equate it to 0. We have x is equal to positive 1 on 6. Okay. Again, this one is horizontal shift. So where it's positive, we are moving towards the right. So that must be 14. So if that is the case, then I will say horizontal shift to the right by 1 on 6 of u. Okay, so this was the coordinate. Negative 2, negative 9. So I'll have, because it's horizontal, I'm focusing on the x, okay? So I have negative 2. Whenever you are moving to the right, you add, okay? When you are moving to the left, you subtract. So I'll add negative 2 plus 1 on 6. Okay, then comma, I'll maintain my negative 9 because I'm not tackling any vertical something. Okay, so finally, I'm going to get, so by the help of the calculator, if I have negative 2 plus 1 over 6 over here, so I can have negative 1.833, comma, then I have what? Negative 9. Okay, so again, I'm going to make use of this coordinate. So what do I do next? So I'm done with this, finally. So I'll now come to this. So I have vertical what? Vertical stretch. So we have vertical. So I think this is the third. This is the fourth. The vertical stretch by a scale factor of 4. If you don't consider the negative 4, okay, absolute value of the negative becomes positive. So we have, whenever you hear stretch, vertical stretch, horizontal stretch, vertical compression, you do multiplication, you don't add. Unlike this where you have to add or subtract. Okay. So the coordinates was negative 1.833, negative 9. Is that also? Then, because it has to be vertical, we are going to consider the y and maintain the horizontal, which is like x. I have negative 1.833, and I have negative 9. So negative 9 times this 4. Okay, times this 4. So I have, so my point becomes negative 1.833, comma, then I have what? Negative 36. You get it that way? As simple as that. Follow the principles. Then the fifth one is, after that I would have come here, but realize that there is negative over here, so I have to also do the negative. Because if you saw previous, negative wasn't there, so we have to ignore negative is here. So this time around, realize that we are trying to negate the whole expression. So it's like you want to negate y. If you want to negate y, what it means is that you are doing reflection in the x-axis. That's what it means. But negative yesterday means now we are negating the whole function, which is y. So negating y means reflection in the x-axis. So you have reflection in the x was r. So for reflection in the x-axis, we have s comma y. So reflection in the x-axis, you maintain the x and negate the y. So this is my point, my current point or my reference. What means I have negative 1.833, comma I have negative 36. So my new set of points becomes I'll maintain my x, which is what? Negative 1.833. Then comma y was what? Negative 36. I'll negate the y again, the y coordinate. Now I'll get a positive 36. So positive 36. Viewers, am I done? Let's see. So I'm done with this. Then the last thing is I'll tackle this part. So this represents either vertical shift or that vertical shift to the upwards or vertical shift to the downwards. Positive implies upwards, right? So we have the sixth one, we have vertical, let's say vertical upwards by 5 units. So for this you don't multiply, you have to either you add or you subtract. So for upwards, downwards, you have to do addition or subtraction, but for stretch, compression, you do multiplication, alright? So I have my current point is negative 1.833, 36. So I have vertical, so I will tackle this, since this will represent my vertical component, okay? This. So I have negative 1.833, then I have 36. And because we're moving upwards, okay, so I'll add, it's positive. So plus what? Plus 5. So finally, I will have this negative 1.833, and I have 41. Let's consider this question. If you have a string, okay, let's see. So if this is my string, alright? If you have a string of length 50 centimeters, so from here to here, 50 centimeters, right? So this is my string. So if you have a string of length 50 centimeters, this is my string, 50 centimeters. What are the dimensions of the rectangle? So let's say I have a rectangle this way, Oh, nice. What are the dimensions of the rectangle of maximum area that you can form with your string? Ah, come on. This is my string. 50 centimeters. So this, okay, that you can form with your string. So this, then I'll come here, then I'll come here, then I'll come here. So by so doing, you start from here to here, from here to here, from here to here, then from here to here. That means you are moving around the plane figure. So simply put, perimeter. Okay, perimeter. So if I have here L is like length, okay, breadth or width, okay, breadth. So if I sum all of them L, so that's be my perimeter, okay, so equal to by L plus B plus L then plus B. So I have P to be equal to L plus L is 2L plus what? 2 what? B. Is that also? Okay. And if you have a string of length 50 centimeters, so that will be my perimeter. So my perimeter here is what? Is 50, which is equal to 2L plus 2B. If I divide 2 by 2, 2 divides here 25. I have L, I have what? B. Okay. So let me call this equation 1. And the question is saying, what are the dimensions of the rectangle of the maximum area? So what is the area? Area of a rectangle is given by what? Length times breadth. Okay, so B. So let me just change this to B. So this will be B. This will be B. Okay. B and B. Alright. And let's say this is equation 2. So now from A, so from equation 1, so from 1, I can either make L the subject or B the subject. If I make B the subject, I'll get B is equal to, then I'll allow L to cross. So I'll have what? 25 minus L this way, okay? This and this crosses. Then, so this will become equation 3. So you put your equation 3 into equation 2. So I have A is equal to L B. Is that also? So I have A is equal to L times B. What is B? B is this. 25 minus my L. So A is equal to L times 25 is what? 25 what? L minus what? L squared. Viewers, here, question says you may write the function in vector form using completing of squares. Okay. So what can we do here? What can we do here? So since you are looking for the maximum area, if you are looking for the maximum area, that means dy dx is equal to what? 0. Dy dx is equal to 0. So now I will differentiate the area with respect to what? With respect to L. Here. With respect to L. So differentiating this, so I have A is equal to 25 minus L squared. So I have dA with respect to L gives me my maximum area of A. So I have dA over dL, okay? We have to differentiate. So if I differentiate 25L, I'll get 25 minus, if I differentiate this, I'll get 2L. Class, if this is your first time, kindly visit my previous lectures on how to differentiate simple given functions, okay? Polynomial functions, how to differentiate functions using the product rule, how to differentiate functions using the chain rule, the quotient rule, and what have you. You will find over there. And also how to differentiate functions using the power rule. So this, the exponent comes here. So there's 1 here, okay? So if I have L squared, there's 1 here. So 1 times 2 is 2. Then I have my L. Then you subtract 1 from the exponent. So you get 1. That's the reason I have 2 L over here. Okay. So you have numbers and variables. When you differentiate it, the variable will go, leaving the number alone. Okay. So now, the A over the L will be equated to 0. Okay. So that you can find for L. Okay. So I have 25 minus 2L is equal to what? 0. So I have 25 is equal to 2L. Divide both sides by 2. Here by 2. So I have L is equal to 12 point. Think this, right? Measured in centimeters, right? Good. They said, what are the dimensions of the rectangle? So I have my L to be this. So how do I find for the B? How do I find for the B? So I have equation 1 and equation what? Equation 2 over here. Is that also? So I can say put L into any of the equations at all. So put L into which equation do you want us to use? Equation 3 here. Into equation 3. So I have B is equal to 25 minus L. Is that not so? I have B is equal to 25 minus L. What is my L? 12.5. All measured in centimeters. So I have B to be equal to 25. So that's 12.5 centimeters. Okay. So that means B and L are the same. Okay. But here we're told that what are the dimensions of the rectangle of maximum area? Alright. So what you have to do is this. You either put, okay, so you have L here, right? The value of L into this to get the maximum area. Alright? You get the maximum area. Or you can put B over there. You know why you can place B over here? Here, we're trying to work in terms of L, so we have to make B the subject and do substitution here, so that we can work in terms of L. We can also work in terms of B. Once they have the same values, it will not alter your answer. Alright? So by substitution, if I want to get the maximum area, so let me call this A max. So this will be my maximum area is I have 25 multiplying L minus L squared. So I have 25 times 12.5 minus 12.5 all squared. So by the help of the calculator, my maximum area 156.25 centimeter squared. So if you can use differentiation, just do this. And you're also given a hint. You can also use completing of squares. So how do we do that? So let's come here. It's just the same ideology, okay? Here, and we go to here. That was here. So I can continue from here using completing of squares. So how do I do that? Okay, so using completing of squares. So by completing of squares, so we have A is equal to 25L minus L squared. This is the same as by rearrangement. I have negative L squared plus 25L. This is positive, so here's this negative and it's here. Then I can do this. I can say that A is equal to, I factor the negative out, I have my negative. So I have it this way, and I have L squared. Then here becomes something like this. It's the same. Negative L squared is negative L squared. Negative times negative gives positive, okay? In that regard. So this is L. So using the completion of squares, for this, we all know that we will multiply this by half, okay? So I have 25 times half gives what? 25 over 2. Is that also? Yeah. So this is what we are going to do. So A is equal to negative, then half L squared minus the 25L. Then plus, so half of this, 25 times half. Half what? Half negative 25 over 2. Is that also? Because it said negative 25 times half. You have negative 25 over 2. Alright? Then I will square that. Okay? So here is addition. So the next one will be subtraction. Then just repeat the same. So I have negative 25 over 2 all squared. This and that, they are the same. Because negative of this, positive of this will cancel negative of this. Usually it is the same as that. Okay, so this is the game or the rule of completing of squares. So I have A is equal to negative 10. Okay, I can decide to do it this way. Okay. I have L, so L squared and this, okay. So I'll bring this together, okay. So I have negative here, negative 25 all over what? Over 2. I'll do it this way. Squared, okay. Then I have negative what? That's negative 25 over 2 all squared. So I have A is equal to L minus 25 over 2 all squared. So I have a negative here. The negative times negative gives what? This is positive. Then I have, in this will give this 625 over 4. This way. So having done this, using the completion of squares to get the maximum takes this. Okay, this will be our maximum area. So this represents our maximum value. So the maximum value, is we take this 625 all over 4, which is equal to, I think, 156.25, because is representing area, the maximum area. See, it's a maximum value. So here, our maximum area, A max, becomes what? 156.25 centimeter squared. Okay, and it occurs when L minus 25 over 2 is equal to 0. Okay, so in other words, this is where it occurs. Okay, this represents the maximum value, and this is where it occurs. Okay, or the equation of symmetry. That's it. Just equate the expression in the parentheses to 0. Okay, so I have L minus 25 over 2 is equal to 0. So L is equal to what? Positive 25 over 2. So my L becomes what? 12.5 centimeters. As simple as that. So these are the two approaches. It's either you use differentiation or completing squares.